Okay. So, let's talk about 21. So, a sporting goods store is offering a 10% discount on inline skates that normally cost $110.99. How much will the inline skates cost with the discount, not including tax? So we're given a couple of pieces of information. The first piece of information that we're given is the total cost. So our total cost in this case is 110. And 99. And they want to know there's a 10% discount.
That's going to be like of?
So there's a couple of ways that you can think about this. One way you can think about this is a 10% discount is the same thing as saying if I divide my total by 10. So for example, 10% is if I took 10 of 100, that would be a 10% discount. So I can think of 10% here a couple of ways. So I can say 10 out of 100 is equal to 110.99, and then solve for what x is. That's one option. And if I do that, right, then this becomes, right, 110.99 times 10, so 0. 9, 0, 1, right? So something like that, which is equal to 100x. I have to divide both sides by 100. And so x then is going to be equal to $11.09. So that's one way that I can solve this problem. But it's a little bit tedious, and it takes a fair amount of time to do the setup. So for the CBEST, one of the other options is to recognize if I think about a decimal place, right, if I divide by 10, I'm moving my decimal place to the left. Just like if I am multiplying by 10, I move my decimal place to the right. So one of the things that I can recognize is that if I'm trying to figure out a percentage, particularly 10%, I can start here and say 1, 2. So it's 11,099. And that's how I can estimate my percent. It's a trick. It's a way to do it a little bit faster. And again, if you get stuck, right, and it's going to be confusing, don't use it, but it is one of the ways that you can save time. So treat this as the whole and move your decimal place to the right. It's the same thing as dividing by 100. So that's the reason why we can use this trick. Okay, questions about that? Again, if you're not certain, this is the most straightforward approach to make sure that you're solving it correctly. You can always do the trick and then check to make sure the whole is correct.
Which answer is it for 21?
So, right, it's going to be the 110
Because I ended up with 99 and 90
minus 1109. Right? And if it's 1109, it should be 99.89.
9 minus 9 is 9?
Let's double check. That doesn't make sense.
Yeah, I got $99.90. So I went for A because it was like closest.
Let's double check. 9, 10%. Oh. You can always check. Let's do it again. All right. 110, 99. Okay, so let's double check our math, make sure that we're okay.
I have the exact same stuff.
You have the same?
Yeah, everything's the
Okay.
same until the.
It's because the discount is 11.099, not 11.
Oh, ha! Thank you. Oh, you guys are so good. That's a great eye. All right, so we're going to have to round up here, right? So let's think about this. If we do this as 11, 10. Here you go. Thank you. So here, 110, 99 minus 1110. And then it would be 99.89. Thank you. A good example of why you would tell your students to write out each of your steps when they're solving the problem and not to skip writing out steps because then it's easier to recollect. Yes?
So when we're dealing with money, it's okay to round up.
It is. It's annoying, and I think they do that on purpose just to make life a little bit more challenging. But a good way to think about it is the penny is a convention in our country, and there might be other currencies in other countries that actually go past the tens position or the hundreds position to a thousands position. So if you're helping students think about how to calculate money, it might depend upon the currency that they're using. Great question. Such an awesome question. And thank you for clarifying. Great eye. All right. Let's do 22. At the beginning of a class period, half of the students in a class go to the library. Later in the period, half of the remaining students go to the computer lab. If there are 8 students remaining in the class, how many students were originally in the class? So there are a couple of ways that you can approach this problem. It's a reasoning problem. They tell you the first time, right? So at the beginning, we have some total x. At some later point in time, we have x divided by 2 because half of the students go to the computer lab. And then they say later on, half of the remainder, so in this case, we know if we took half to the computer lab, we still have half left. Half again, right? Oh, so this, sorry, let's do this. Half is library, next half is computer lab. Sorry about that. So half go to the library, half go to the computer lab, and then we're left with 8. So there are a couple of things that we can do to make our life a little bit easier here. So one way is you can think about this just in the following. Half of a whole, right, is 1/2. If I take half of a half, right, that's the same thing as a quarter. So that means I have a quarter left. So if I multiply 8 by 4, my total is 32. So that's one way that you can think about it. Let me give you the other 2 ways to think about it. So here, right, we have x divided by 2. Here, we have x divided by 2 again, right? So a half of a half. So if you're thinking about a half of a half, right, you can think about it this way. Half, right, of $1 would be 50 cents, right? Half of 50 cents would be a quarter, which means that you would have a quarter left. So that's one way that you can think about it. is you have a half remaining. Half of that half is a quarter, which means that what you have left is a quarter. If 8 is a quarter, right, I could say 8 out of x is equal to 1 over 4. Then x is equal to 8 times 4, or 32. Yes?
Why would it not be 16? Because it says there's 8 students remaining in the class. I feel like that would be the beginning part. And if half of the class leaves and there are 8 left, would that make 16?
But here's the challenge, right? So if we read that really carefully, it says half of the students go to the library. So we take whatever our total number is and half of that is gone. So we have a half remaining, right? We're going to take another half of that. So it's a half of a half that goes to the computer lab.
Oh, so it's half of the students remaining, not half of the half that went to the
Yes,
library?
exactly. Which is, so this is why reading it is really tricky, right? Because the language can be super confusing. So for me, I actually usually have to read these problems. You're going to laugh at this. I read them forwards, and then I read them backwards to circle the most important words. So, for example, I would read backwards to say how many were originally, so that means my total. If there are 8 remaining, so I circle the remaining. And then I go backwards and I say half of the remaining, so I circle half and remaining. And then I go back and I say half again. So some of it is figuring out the logic of what are you dividing by. So another way to think about this is I have my total. I have my total divided by 2, right, which gets me half of my total, divided by 2 again, which gets me 8. And then I can do the same thing. If I know it's half of the total divided by 2, that's the same thing as a quarter. And that's how I can get to this ratio. That's another way to think about it. So the wording really matters, and it can be tricky.
Also, they're all 25 cents each, right?
Well, so this was just to show you the principle of a quarter, right? If I take my total and I divide by half, that would be 50 cents. If I take my 50 cents and I divide it in half again, that would be a quarter, right? And I would have a quarter remaining. So that's just to show the argument. Questions? It's a tricky reasoning problem, so it's useful to be able to ask if you need clarification. Take a moment and reflect on your learning while I erase. I feel like these beautiful white boards are becoming more like gray boards. Okay. All right, here we go. Everybody okay? All right, let's do 23. So, Peter works 38 hours per week and earns $7.25 per hour. His employer gives him a raise that increases his weekly gross pay to $307.80. What is the increase in Peter's weekly gross pay? So, there's some information. They say 38 hours. They tell me that he earns $7.25 per hour. So, gross pay just means the total. So I need to figure out how much Peter makes. So 7.25 times 38. So 16 and 4 is 2, 8, 0, 5, 1, 7, 21. All right. So Peter makes $275.50 for every 38 hours he works at the rate of pay. But they tell me in the problem that his employer increases his salary to $307.80. So what's the increase? Well, I have to subtract his base pay from the total amount that he's getting. So here, 3, 2. So the increase would be $32.30. I think in terms of this problem, there are a couple of things that you can eliminate right away. You can eliminate E, right? Because there's no way that the increase in his weekly gross pay is $300.55. That would be lovely, but it's probably not going to happen. And, right, you can also eliminate D because you were savvy enough to recognize that this is your calculation, but you're not done yet, right? This is the total amount that he makes, but they're asking for the increase, not the total amount that he makes. So you can ignore D, which really leaves you A, B, and C to choose from, and that's where I think you have to do the math in order to be sure. Okay, let's take a look at 24. Go ahead and take a moment and read the question while I draw a picture. Aguilar Manufacturing Company packages a product for shipping by wrapping tape around the package as shown in the diagram. An additional 10% length of tape per package is needed for the overlap. What is the total length of tape needed per package? So, this problem has a couple of pieces that I want to make sure to make sense of. So all I care about is the tape, but it's tape around a box. And you'll notice that the challenge of drawing three-dimensional images is that right now I only see half of the image, right? The other half isn't shown. And if you're like, what are you talking about? Well, here's my image as drawn. Here's the part that's not shown, right? So I have tape on the underside. I have tape across. And then, right, I have tape here that I can't see. Okay? So, one of the things that we're going to have to do when we're solving this problem is we're going to have to multiply by 2 because whatever we see, there's a half that's hidden. Okay, so they want the total length of tape needed per package. Well, the first thing I have to do is figure out the total length of tape and then figure out the 10%. So they tell me that this is 5. So I have 5, 5, 5, 5. So that's going to be 20. But remember, I have hidden, so I have to multiply that by 2. So that's going to be 40. And then I have an additional 5 here. So 5, 5, 5. So that's 15 times 2, which is 30. But I have 2 of those. So I can do another 15 times 2, which is 30. So my total here, right, is 100 inches. But you'll notice that they were, in the problem, really specific, and they said an additional 10% length of tape per package is needed for overlap. So what is 10% of 100? Well, in this case, it's really easy, right? Because my total is 100. So my additional amount is just 10. So it's going to be 110 inches. Does that make sense? So, couple of pieces. I think calculating the percentage is really easy. Another way that you could do that is you could literally just go in by 1 decimal place, and that would tell you that that's 10%. That's another way to be able to get there. So 100 plus 10 is what you're looking for. All right, take a moment and reflect on your learning. Check in. Check a look at your pluses and minuses. See if you're good to go or if you still have remaining questions. Wait. Not a problem. We'll happily wait. Not a problem at all.
So the first 15 times 2
Uh-huh.
because the other side of the box.
Yep.
And then the other 15.
It's because there's another strap of tape.
Oh, okay.
Yeah?
I'm trying to draw a big one, but
And again, any other questions? That one's kind of tricky because it requires some visualization. All right. So here we go. Let's do 25. So it says Arturo is driving at a speed of 50 miles per hour. At 2 o'clock, he sees the following sign. He continues at the same speed. At 2:30, how far from Canaan will he be? So in this case, they tell us that it's 50 miles per hour. So this distance is 0.5 hours. So if he is traveling 0.5 hours, that means if his speed is 50 miles per hour, and he's traveled 0.5 hours, then you can use dimensional analysis, and that means he will travel 25 miles. Then we have to look at the sign, and so it says Canaan is 62 miles away. So we think about it this way. Here's where he is at the time he sees the sign. Here's Canaan, 62 miles. At 2:30, he's traveled 25 of those total miles, and he has X miles remaining. So you can say 25 plus X is equal to 62. If you want to get X by itself, you subtract 25 from both sides. So X then is equal to 37. So this is kind of tricky in that there's a setup piece that you need to think about. The setup being, oh, I'm coming up with a time, so how long in seconds, hours, minutes, and then the distance, right? And you're going to relate those two through dimensional analysis. Once you have those, then you're going to think about the information from the sign. So here's where I started. Okay. By 2:30, I've traveled 25 miles, but the total distance to Canaan is 62. So 62 minus 25 gives me my remaining distance. Questions about that setup? Okay. Kaiko spent the day watching and counted 34 more birds in the morning than in the afternoon. So morning, afternoon. So the morning is X plus 34. The afternoon is just X. So 34 more birds in the morning than in the afternoon. She counted a total of 76 birds. So X plus 34 is equal to 76. So then I have 2x plus 34 is equal to 76. I have to subtract the 34 from both sides. So x then, I have to divide by 2. So x is equal to 21 birds. So the most important part here is actually the setup of the problem. You want to make sure that you're reading in order to make sure that your relationships are correct. So it says 34 more, keyword there is more, than, and so they don't give you the letter X. You could use any letter if you want to do B or X or Y, it wouldn't matter. But it's this idea of you have information that's an unknown, and so you're going to take what you do know relative to the unknown and come up with an overall expression. Questions about how to solve this problem? Okay, take a minute and reflect on your learning for 25 and 26. You good to go? Do you need a little bit more time? What questions might you have?
Oh, can we slow down number 25 for a minute? Like, how did you, how we got 37 miles?
How we got 25 miles?
No, it's 37 miles.
So the 37 miles here, right, this is a two-step problem.
Because you put down 0.5 hours, that's...
Yep, so that's half an hour.
Okay.
Okay, and I know that Arturo is traveling 50 miles. So if I travel 50 miles, but I've only traveled, and that's per hour, but I've only traveled half of that. So I have to divide 50 by 2. That's what gets me 25 miles.
Okay, so you put 50 miles to 3.
So 50 miles divided by 2. That's how I get here. Another way to say this is 50 divided by 2. Right? Because 2 30 minutes equals an hour. Then once I know that 25 miles, I know that at this point, I've already traveled 25 miles.
Oh, so that's where it came from, the 5.
Correct. That is correct.
Thank you.
And then the overall is 62. So I have an overall expression of 25 plus x is equal to 62. Okay. Everybody good? Do you want a minute just to think? Right? Reason? Or are you good to move on? Good to move on? Wait? Okay, thank you. All right. go. Same type of idea, but it's a slightly different representation. It says solve for y. So y minus 2 plus 3y is equal to 10. So in this case, I'm going to combine like terms. Like terms include my y's. What's not written here that I might want to include is the 1 in front of the y. So 1y plus 3y is equal to 4y. So if I simplify my expression then, it's going to be 4y minus 2 equals 10. I'm going to add 2 on both sides. Now I have 4y is equal to 12. Notice I might need to divide by 4 on both sides to get y by itself. So y is equal to 3. So if we think about the order of steps that we did here, the first thing that we did was we combined like terms. We combined anything that had a y together. Then we recognized that we needed to combine anything that was just a number. So we moved our negative 2 over to the right-hand side by adding 2 to both sides. Then 10 plus 2 is what gets us to 12. And we have 4y, but y is still not by itself, so we're going to need to divide by 4 on both sides. So y divided by 4 gives us 3. Let's do 28. A refrigerator in a school cafeteria is partially filled with 42 sandwiches. There are 13 turkey sandwiches. There are 14 cheese sandwiches. And there are 15 egg sandwiches. By the end of the lunch period, 21 sandwiches have been sold. Which of the following facts can be determined from the information given above? A, the number of cheese sandwiches sold. Well, there's not really enough information in the problem to be able to figure out the number of cheese sandwiches sold. We know the total number of cheese sandwiches, but we don't have any other information related to the number of cheese sandwiches. Likewise for B, we don't have the cost of a turkey sandwich. That's not information that's included in the problem. At no point in time do they tell us how much the sandwiches cost. Bless you. The total number of sandwiches that can be placed in the refrigerator. Well, that doesn't really help us either because it just says that it's partially filled. It doesn't tell us how much is remaining or how much space is left. And likewise, the problem didn't tell us the total dollar sales of sandwiches during the lunch period. We don't know that information. So the only choice left is E. We're going to hope that that one's the correct answer. The number of sandwiches remaining in the refrigerator after the lunch period. Well, this one I can answer, right? Because I have these two pieces of information. So 42 minus 21 would tell me that I have 21 sandwiches remaining. So that I can answer. Take a moment and reflect on your learning. Did the setup for those problems make sense? Or do you have any questions? Am I okay to erase this one? Thank you very much.
Oh, so 42 minus 21, that makes 21.
Yep.
That reminds me what I did in 3rd grade.
Yep. Okay, here we go. Let's take a look at 29. Wei Jen and Sue are going to drive across country. To reach their destination, they plan to drive about 400 miles each day for 5 days. If gasoline costs an average of $2 per gallon, approximately how much money should they budget for the gas trip? Oh, how much should they budget for gasoline on this trip? Which single piece of information is necessary to solve the problem above? Okay, so let's think about this. If we're thinking about A, the number of times they have to stop for gasoline. Well, we don't actually know that because we don't know how well their car, right, uses that gasoline. We have no information about the efficiency, so we can ignore A. We don't know enough information to be able to answer that. B, the number of miles the car travels per gallon of gasoline. So you can actually use the information to calculate this. You know the 400-mile trip. You know that that's each day. You know the average cost of gasoline per gallon. And so you can figure out the total number of miles, right? And then figure out the number of miles the car travels per gallon of gasoline. So you could use B. But let's just check to make sure that there isn't any other answer that would make more sense. C, the number of miles Wei Jin will drive. Nope, not given in the problem. We're told that Wei Jin and Sue are driving, but we're not told who the driver is. D, the total distance of their trip. So they plan to drive 400 miles each day for 5 days, but at this point in time, right, the total distance of their trip is something that we don't know, right? We know they're going to drive cross country. We know they're reaching a destination, but we don't know if that destination is the final destination or just part of the way on their trip. And then number E, the number of miles the car travels per hour. That again is an information that we're given. So this is a good example of a problem where you might read through the answers and have to think about what in the problem would allow you to calculate that information. Let's do number 30. Maria left her home at 9 a.m., ran 3 miles to the lake, ran around the lake twice, and then ran home along the same route for a total distance of 10 miles. What was Maria's average jogging speed? So what single piece of information is necessary or required to solve this problem? So A, the distance around the lake? No, we don't need to know that. B, the time that she returned home. Yeah, in order to be able to figure out Maria's average jogging speed, we'd have to know the time she started and the time she finished, because that's a rate. It's a rate expression. So we'd have to know the total time in order to be able to calculate that. Number C doesn't work because the amount of time she stopped to rest, that's not going to help us solve this problem. Number D isn't going to work because the length of her jogging stride also wouldn't give us the information that we need. And number E, the amount of time it took her to run from the lake to her home, doesn't help us because it says she ran around the lake twice and then ran home. So we actually need her total time of the run in order to be able to figure out her average jogging speed. Okay, go ahead.
Being B.
Yep, B is the correct
So
answer.
how are we supposed to solve the math problems with these two?
But they're not a math